Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the angles and parallel lines practice questions. If you need any extra help on angles and parallel lines, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 25, there's a dedicated video tutorial there on angles and parallel lines. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says, in the diagram, the line AB is parallel to the line CD. So these two lines are parallel to each other. And part A says, work at the sides of the angle marked X. So we need to find the size of this angle. Now, if we have a look here, this angle looks like it's the same size as the 72-degree angle. And it is, because they're what we call corresponding angles. If you watch that video, Angles and Parallel Lines on Corbettmaths, you'll see that these are corresponding angles. If you look at these angles and these angles, this one's in the top right corner. This is in the top right corner of these angles. So they're corresponding to each other. They're the same. So part A says work at the size of the angle marked X at 72 degrees, and then give a reason to your answer. I'm going to explain that they are corresponding angles. So let's write that down. And that's it. I've just explained that X and 72 degrees are corresponding angles, so they're equal. Okay, let's have a look at our next question, question number 2. Question number 2, we're told that A, B and CD are parallel. So these two lines are parallel to each other. You can see that with two little arrows. And we've been asked to work at the size of the angle marked Y, the size of this angle here. And part A says to work at the size of the angle, and part B is to give a reason for our answer. Now, if we turn our head sideways, you can see the Z shape here. So that means that these two angles are equal to each other. They're alternate angles. So Y and 60 degrees are equal to each other. So that means that Y is 60 degrees because these two angles are alternate angles. And again, if you need a recap on that, if you go to that Corbettmaths video on angles and parallel lines, that'll explain that. So these two angles are equal to each other because they're alternate angles. So work out the size of the angle marked Y, that's 60 degrees, and give a reason for our answer. Let's do that. And that's it. I've just explained that Y and 60 degrees are alternate angles, so they're equal to each other. Okay, let's have a look at our next question. So question number 3. So question number 3, we've got these two parallel lines. These two vertical lines are parallel. We can see that with the arrows. And we've been asked to work out the size of this angle marked X. So we want to find the size of this angle here. And part B says to give a reason for our answer. Now, if we've got two parallel lines like here and here, these angles here and here, they add up to 180 degrees. They're what we call co-interior angles. This acute angle and this obtuse angle will add together to be 180 degrees. So that means if we want to find the size of this angle X, if we just take 111 degrees away from 180 degrees, that'll tell us what's left for X. So these two angles will add together to be 180 degrees, and they're called co-interior angles. If you've got two parallel lines and you've got that line that crosses them, the acute angle here and this obtuse angle here, these two angles will add together to be 180 degrees. Okay, so work out the size of the angle marked X. That's an uncalculated question, so we're going to have to do 180, subtract 111, and then we're doing our subtraction. 0 take away 1, let's borrow, that's now 7 and a 10. 10 take away 1 is 9, 7 take away 1 is 6, and 1 take away 1 is 0. So the answer is 69 degrees. So the size of this angle marked X is 69 degrees. And let's explain that. And that's it. I've just explained that co-interior angles add together to be 180 degrees. So X and 111 degrees add together to be 180 degrees. So therefore X is 69 degrees. Okay, let's look at our next question, question number 4. Okay, let's have a look at our next question, question number 4. So question number 4, we've got these pair of parallel lines, K, L and MN. So these lines are parallel to each other, and we can see that with these arrows here and here. So these two lines are parallel. And we've been asked to find the size of this angle, and part B is to give reasons for answers. So there's quite a few different approaches we could use for this question. So I'm going to try to explain each one now. Okay, so in terms of our first approach, one approach we could use is to consider alternate angles. If we have a look here, we've got this backward Z shape, so here, and so that means that if this is 59 degrees, this is 59 degrees. There are alternate angles. This angle and this angle are equal to each other because they are alternate to each other, using alternate angles. So we can find the size of that angle. Then if we look at this diagonal line, that's a straight line. So that means that 59 degrees and the X, they make a straight line. So if we do 180, take away 59, that's equal to 121 degrees. So that means that X is 121 degrees. So that's one approach, by considering that these are alternate angles, finding the size of this angle, then considering the straight line and finding the size of that angle. So that's one approach, and I'm going to actually explain that one in a minute. Actually, I'll explain that one now. So part A says, what's the size of this angle? X is 121 degrees, because obviously this is 59 degrees, that's 59 degrees are alternate, and then these two make a straight line, and if we take 59 away from 180, we're left with 121. So this is 121 degrees. So let's explain that. Part B says give reasons for your answers. So let's do that. So in part B, we're asked to give reasons for our answers. So my first thing I've written down is that angle MCB, so angle MCB, this angle, the 59 degrees, is equal to angle CBL, so CBL, this angle. So these two angles are equal to each other as alternate angles are equal. And then the second thing that I've written down is angle ABL, so angle ABL is equal to 121 degrees, as the angles in a straight line add together to be 180 degrees. So that means that that's equal to 121 degrees, and that's it. So that's how I would probably answer that question myself. Now I'm going to go through a few other approaches now. Okay, so just change colour of ink to blue, just to show this is another approach that we could use. So that first approach was to consider alternate angles. Another approach would be to use corresponding angles. So if this angle is 59 degrees, you could then say that this angle up here is 59 degrees because they're corresponding angles. This one and this one, they're corresponding, they're equal to each other. And then you could take that away from 180 degrees to find that that's equal to 121 degrees. So that's another approach. So in that case, I would say the angle MCB equals angle KBA as corresponding angles are equal to each other, and then the angle ABL is equal to 121 degrees as the angles in a straight line add together to be 180 degrees. So that's another approach that we could use. You could use a similar approach where we find the sides of this angle, considering the straight line first of all, so that's 121 degrees, and then say that this angle is equal to that one because they're corresponding angles. That's another approach that you could use. Another approach you could use is actually consider those co-interior angles like we done in question 3, so that this angle and this angle add together to be 180 degrees because they're co-interior, this one and this one. So if this is 59, if you take that away from 180, you get that's equal to 121 degrees. So you can say that angle MCB and angle KBC add together to be 180 degrees as they're co-interior angles. So angle KBC is equal to 121 degrees. Then you could say that x equal to 121 degrees as vertically opposite angles are equal to each other. If you've got straight lines across each other, the opposite angles are equal. So that's 121 degrees. So there's quite a few different approaches you could use in this question. So whichever one you prefer. I probably would go for those alternate angles to begin with and find the size of this one here is 59 and then finding x to be 121 degrees. But as long as you use your approach and then give your reasons for that answer. Okay, let's look at our next question, question number 5. Okay, so question number 5, we're told that in the diagram, AB is parallel to CD. So this line is parallel to this line. And we've been asked to find the sides of the angle marked X. So we want to find the sides of this angle. Now here's our parallel lines. We've got these two angles inside of the parallel line. So these two angles are co-interior angles. This obtuse angle and this acute angle will add together to be 180 degrees. So if we do 180 degrees, take away 135 degrees, we get that's equal to 45 degrees. You could use your column subtraction there if you wanted to. So x is equal to 45 degrees. And so that's part A. Part A is to work out the size of the angle marked X. It's 45 degrees. We've been asked to give a reason for our answer, so let's explain that. And that's it. I've just explained the angle. If we go back up here and look at this, I've explained the angle AEF and angle CFE are co-interior angles, so they add together to be 180 degrees. So that's why that's 45 degrees. Okay, part B. Part B says write down the value of y, so we want to write down the value of this angle here, y. Now here we've got two straight lines across each other, so the opposite angles are equal. So if this angle is 45 degrees, this angle is 45 degrees, so y is 45 degrees because it is vertically opposite to the other 45 degrees. So let's explain that. And that's it. I've just explained the angle CFE, CFE and GFD. Those angles are vertically opposite, so are equal to each other. So that's why it's 45 degrees. Okay, let's look at our next question. Okay, so question number 6. Question number 6, we're told that the line AB and CD are parallel, and we've been asked in part A to work out the size of the angle marked X. So we want to find the size of this angle marked X. So if we have a look here, let's have a look at this. We've got these two parallel lines, and then we've got this straight line that crosses them, JM. I'm not going to look at this line EH yet. I'm just going to focus on this line here. Now, if I look at this line, the 105 degrees and the X, they're both, if we look at these angles here, and these angles here, this one's in the top left-hand corner of those angles, and this angle's in the top left-hand corner of those angles. So that angle and that angle are corresponding angles. They're equal to each other. So X is 105 degrees as their corresponding angles. So let's explain that. So I've just explained the angle JKA, so JKA, this angle here, and angle KLC, this angle X, these two angles are corresponding angles. They're corresponding angles, so are equal. Okay, let's have a look at our next part, part B. So part B says work out the size of the angle marked Y, and we've not actually been asked to give a reason for our answer, so we just need to find the size of this angle here marked Y. So if we want to work out the size of this angle marked Y, well, I'm now going to look at our two parallel lines, the line AB and CD, and we've got this diagonal line that crosses them. I want to find the size of this angle here. Now, there's quite a few different approaches we could use. Thinking back to, I think it was question 4, there's a few different approaches. One approach is to say, well, if this angle here is 65 degrees, this angle down here would be 65 degrees. They're corresponding to each other. If we look at these 4 angles and these 4 angles, the one on the top left and the one on the top left here, they're equal to each other because they're corresponding angles to each other. And then this angle and this angle, they're in a straight line. So that means that if we take the 65 degrees away from 180 degrees, we'll find the size of the angle marked y. So let's do that. 180 degrees, take away 65 degrees would be equal to, well, if we took away 60, that's 120, and another 5 is 115 degrees, so 115 degrees. That means our missing angle marked y is 115 degrees. So we found the size of that angle y, it's 115 degrees. So that was one approach, using the corresponding angles. Another approach could have been to, instead of considering the corresponding angles, we could have considered vertically opposite angles. So if this angle is 65 degrees, that angle 65 degrees. And then we've got our co-interior angles. So we then take 65 away from 180 and we get that angle is 115 degrees. That's another approach. Another approach is to consider the straight line. So this angle and this angle, get that one to be 115 degrees by taking 65 away from 180 degrees. And then we've got alternate angles. So there's quite a few different approaches you could use to find the size of that angle y, and it's 115 degrees. And the question doesn't ask us to give any reasons, so that's it. We've completed it. Okay, let's look at our next question, question number 7. Okay, so question number 7, it says, on the diagram, RS, so the line RS, is parallel to the line TU. So these two lines are parallel to each other, and we've got all the angles are labelled A, B, C, D, E, F, G, H. And part A says, which angle is vertically opposite to angle G? So angle G is here. The one vertically opposite it, well, we'll look at the two lines that cross each other, we'll look at the angle G, and we'll find the one opposite it, which is angle F. So these two angles are equal to each other, and it says, which angle is vertically opposite to G? It's F. Okay, part B. Part B says which angle is corresponding to A. So if we have a look at A, if we look at this collection of angles at the top here, A, B, C, and D, A is in the top left-hand corner of those angles. And if we look, we've got this transversal that crosses the two parallel lines. If we now look at this collection of 4 angles, E is in the top left corner of those. So angle A and angle E are equal to each other, because obviously that transversal cuts those parallel lines in the same direction. So that angle will be the same as that angle, so they're corresponding to each other. So A is corresponding to E. So let's write that down. So E, angle E. And actually, if we have a look here, A would be corresponding to E, B would be corresponding to F, C would be corresponding to G, and D would be corresponding to H. Okay, let's look at our next part, part C. Part C says which angle is alternate to C. So let's have a look here. We've got C here, alternate angles, so they're your Z angles. So if we have a look at this Z, now make sure you call them alternate angles and not Z angles. So angle C, if you imagine that Z, angle C is alternate to angle F. They're alternate to each other. They're both equal to each other. They're alternate angles. And angle D would be alternate to angle E. They're alternate to each other as well. So C is alternate to F and D is alternate to E. So we're asked which one's alternate to C. That's going to be F. So F. Okay, so let's look at our next part, part D. It says which angle is corresponding to H. Now we've actually talked about the corresponding angles already. So H is the bottom right one. So as you notice here, D is the bottom right. So H and D are corresponding to each other. So the answer is going to be D. D is corresponding to H. Okay, and then our last part, part E, it says which angle is alternate to angle D. So if we go up and have a look at angle D's here, and the one alternate to that would be angle E. They're alternate angles, that backward Z shape. You've got this obtuse angle, you've got this obtuse angle, they're going to be equal to each other. So the answer will be E. So the angle is E. And that's it. Okay, let's have a look at question number 8. So question number 8, we're told that AB, the line AB is parallel to the line CD. We've got some other lines here. We've got PS, that's a line that crosses both AB and CD. And then we've got the line RT, and that joins up this point here with this point here. And we're told the angle CRQ is equal to 154 degrees. And we've been asked to find the size of angle Y, this angle here, angle RTB. So we want to find the size of that angle, and we've been asked to give reasons for your answer. So what I'm going to do is I'm going to find the size of this angle to begin with, and then what we'll do is we'll write down the reasons. We'll actually talk about the reasons as we're doing it. Okay, so first of all, we want to find the size of this angle. Now, there may be more than one approach to this question. The approach that I'm going to do is I'm just going to use one approach here. So here we've got angle CRQ, and that angle is 154 degrees. Now, I notice here we have got alternate angles. So this angle here, angle RQT, would also be equal to 154 degrees. They're alternate angles. So that's the first thing I'm going to do is I'm going to work out the size of that angle there. And actually, let's write down what we've done there. So I'm just going to write down that reason. So that angle is 154 degrees, so because obviously it's equal to that one. So if we're just written down the angle CRQ equals angle RQT, because the alternate angles are equal to each other. Now if we notice here, we've got two little dashes. There's a dash here and a dash here. That means the line joining R and Q is the same length as the line joining Q and T. So that means that triangle QRT, is an isosceles triangle. So obviously here we've got an isosceles triangle as these two sides are the same length, and that means that these two angles here and here will be the same size as each other. So this angle is the same size as this one. So if we wanted to work out the size of this angle here, what I would do is I would take 154 degrees away from 180 degrees. So I'm going to do 180 degrees, subtract 154 degrees, and that's equal to 26 degrees. So that means that this angle plus this angle is 26 degrees. Then if we take our 26 degrees and we divide by 2, that's equal to 13 degrees. That means that this angle here is 13 degrees. So if we find the size of that angle, this angle here would also be 13 degrees because that is an isosceles triangle. So now we've found the size of that angle. Actually, let's write down the reason. Let's write down what we've done there. So it's just written down that as triangle RQT is isosceles, angle QRT, so that angle, is equal to angle QTR. So those two angles are equal to each other and they're both 13 degrees. And I've also said that the angles in a triangle add to 180 degrees. So that's why we've taken 154 degrees away from 180 degrees and halved it to get 13 degrees and 13 degrees. Now we want to find the size of angle RTB, this angle here, angle marked Y. Now if we have a look here, we've got this 13 degrees and the angle we're trying to find. So these two angles will add together to be 180 degrees. So if we take 13 away from 180 degrees, we'll find the size of angle Y, and that's going to be 167 degrees. So let's do that. And that's it. So I've written down, as the angles in a straight line add to 180 degrees, y is equal to 167 degrees. Because as these two angles add together to be 180 degrees, subtract 13 degrees would be equal to 167 degrees. And that's the angle we're trying to find. And the reason is these two angles will add together to be 180 degrees. And that's it. So find the size of angle y, that's 167 degrees. And there are reasons. So I started off with using the alternate angles and talking about the fact that those two angles would be equal to each other. Then I said that this is an isosceles triangle, so we had our 13 degrees and 13 degrees, and then I talked about the fact that we have a straight line, so these two angles will add together to be 180 degrees, and that's it. Now there may have been another approach to that question, but that's the approach that I've used. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 9. So question number 9, we've got this diagram, and Nigel says that the lines CD and EF are parallel to each other, and Tim says the lines CD and EF are not parallel to each other, and we've been asked who is correct. So who's correct, Nigel or Tim? So in other words, are these two lines, these two diagonal lines, are they parallel or not? Now, if I wanted to show that these two lines are parallel to each other, CD and EF, what I would do is I would say, well, if these two lines are parallel to each other, these would be our co-interior angles, and co-interior angles always add together to be 180 degrees. So if these two angles add together to be 180 degrees, then I know that these are co-interior angles, and then that means that the two lines would be parallel to each other. So let's say if these two angles add together to be 180 degrees. So 83 degrees plus 97 degrees would be equal to, well, 83 plus 7 is equal to 90, plus that over 90 is 180 degrees. So these two angles add together to be 180 degrees. That means they're co-interior angles. So that means the two lines are parallel to each other. So that means the two lines are parallel. So Nigel's correct. So who's correct? Nigel. And we've been asked to give a reason for our answer. Well, those two angles add together to be 180 degrees. That means they're co-interior angles. That means the two lines are parallel. So let's write that down. And that's it. I've just written down that as the two angles add together to be 180 degrees, they're co-interior angles, and that means the two lines are parallel. And that's it. Now, that's one approach to that question, and that's the approach that I would use. I would add those two angles together and see if they add together to be 180 degrees, and if they do, then they're co-interior angles, and the two lines are parallel. Now, another approach you could have used is actually to carry on the length of the line DE, and carry on the line like so, and to find the size of this angle, and to find the size of this angle. So, take 83 away from 180 degrees, and see what you get, and to take 97 away from 180 degrees and see what you get. So if we do 180 take away 83 degrees, that's equal to 97 degrees. So that means that this angle is 97 degrees. And then here, if we take 97 degrees away from 180, so 180 take away 97, that's going to be equal to, taking away 100 would be 80, and so it means that taking away 97 would be 83. So this angle is 83 degrees. And if we have a look here at the angles and look at these lines, you can see they're going in the same direction and they're both going off the line DE. So that means that they're going to be parallel to each other. So you could explain that. You could explain that obviously here you've got CD and the angle to the left of it is 97 degrees and the angle to the right of it is 83 degrees. And likewise with the line EF, the angle to the left is 97 degrees and the angle to the right is 83 degrees. So that means they're going in the same direction. So that means the two lines are parallel to each other because they're going in the same direction and they'll never meet each other or cross each other. So that means they're parallel. So that means that Nigel's correct. Now, I would have used the co-interior angle approach. That's the approach that I would have used, but some students may use that approach. Okay, let's look at our next question, question number 10. Okay, so let's have a look at our next question, question number 10. So question number 10 says that the lines PQ and RS are parallel. And as you can see, that's shown with the two little arrows. And we've been asked to work out the value of X. We want to find the size of this angle here. And the question, it doesn't actually ask us to give any reasons, so we just need to work it out. We just need to work out the size of this angle here. Okay, so in terms of finding the size of this angle, the first thing I notice is we've got two lines across each other, RQ and PS cross each other, and here we've got 105 degrees. So that means the opposite angle, this vertically opposite angle here, will be 105 degrees as well, because vertically opposite angles are equal to each other. Okay, so we found the size of that angle. Now let's have a look at our parallel lines. So we've got this line's parallel to this one, and we've got this line here. So I can see there's an alternate angle here. We've got this Z shape, so we've got our alternate angles. So if this is 54 degrees, this angle up here would be 54 degrees also, because these are alternate angles. Now we want to find the size of this angle here, X. Now if we have a look at this triangle, we've got the size of two angles. So if we add these two angles together and take it away from 180 degrees, we'll find the size of X. So let's do that. So 105 degrees plus 54 degrees, that's going to be equal to 159 degrees. That's 159 degrees. And then if we do 180, take away 159, that's equal to 21 degrees. So that means the size of this angle here, labelled X, is 21 degrees. So X is equal to 21 degrees. And that's it. So we've answered that question. And we were just asked to find the size of the angle, so we don't need to worry about writing down our reasons. So the size of this angle, X, is 21 degrees. So let's write that down, 21 degrees. Okay, let's have a look at our next question. So question number 11 says that triangle CDE, this triangle, is isosceles, and we can see that with the two little dashes here and here. So the length of CE is equal to the length of the line DE. So that line is the same length as that line. So that means this is an isosceles triangle, and if these two lines are equal to each other, these two angles here and here will be the same size as well. And we've been told the angle CED, so CED, this angle is 30 degrees. And the question says to work out the size of this angle here, X. So we want to find the size of that angle, X. So if I wanted to find the size of this angle, I'm going to look at this triangle to begin with, this isosceles triangle. And we know that this angle is the same size as this one. So if we take 30 degrees away from 180 degrees, if we do 180, take away 30, that's equal to 150 degrees. So that means that this angle plus this angle is 150 degrees. Now, if we take our 150 degrees and divide by 2, because these angles are the same, if we divide by 2, that's equal to 75 degrees. So that means that this angle here is 75 degrees, and also this angle over here is 75 degrees. So that's fantastic. Now we want to find the size of this angle here, X. Now if we have a look at our two parallel lines, if we have a look at this line and this line, we can see we've actually got the Z shape. So that means we've got alternate angles. So angle DCE, this angle, will be the same size as angle CEF. So that means X is equal to 75 degrees because it's alternate to that angle. And the question doesn't ask us to write down any reasons, so we just needed to work out the size of this angle X here at 75 degrees. So X is 75 degrees, and that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says, in the diagram, AB is parallel to CD. So as you can see, these are two parallel lines, AB and CD, and that's shown with the two little arrows here and here. And in this question, we've been asked to work out the size of the angle marked X, so the size of this angle here, BDC. So we want to find the size of that angle, and we must show workings. Okay, so to find the size of that angle, there's a few different approaches we could use. To begin with, what I'm going to do is I'm going to find the size of this angle here. I know that these two angles make a straight line. So if I do 180, take away 116 degrees, that's going to be equal to 64 degrees. So that's 64 degrees. So that means the size of this angle is 64 degrees. Okay, now in terms of finding the size of this angle X, there's a few different approaches we could use now. We could find the size of this angle here because we've got two angles inside of this triangle. So if we add these two angles together and then take that away from 180 degrees, we can find the size of this angle. And then because this line's parallel to this line, that means that this angle and this angle will be corresponding angles. So you've got that F shape there and there. I like to call them corresponding angles. So we've got these corresponding angles here and here. So once you find the size of this angle, X would be the same. Alternatively, what we could do is we could look at this angle and say it's corresponding to this angle, and then consider the large triangle and add together the 51 and the 64, and then take that away from 180 degrees, and that'll be the size of this angle x as well. Okay, so let's find the size of this angle x. So what I'm going to do is I'm going to find the size of this angle to begin with. So I'm going to do 51 degrees plus 64 degrees. So 51 plus 64, let's see what we get. 1 plus 4 is equal to 5, so put the 5 down, and then we've got 5 plus 6 equal to 11, so that's 115 degrees. Now we're going to take that away from 180 to find the size of that angle. So 180 subtract 115, and then 0 take away 5, well let's borrow, so that's now a 7 and a 10. 10 take away 5 is 5, 7 take away 1 is 6, and 1 take away 1 is 0. So that's 65 degrees. Okay, so we now found the size of this angle here. And as I said earlier, this line is parallel to this line, so that means that this angle is corresponding to this angle. So that means that x is 65 degrees, so x is equal to 65 degrees. So let's write that down, that x is 65 degrees. Now the question said we must show your workings, so we've shown our working out. We've done that, we've shown our workings. You don't need to give full reasons because the question hasn't asked for reasons, it just says you must show your workings, so we've done that. Okay, let's have a look at our next question. So question number 13, we've got that CE and FI are parallel lines, and we can see that with these two little arrows. We're told the angle EDH, so EDH is 50 degrees, yeah, we can see that. Angle DGF, so DGF is 100 degrees. And then the question carries on, it says, show given reasons, so we need to give reasons, the triangle DGH, this triangle is isosceles. Now to do that, what I'm going to do is I'm going to find the three angles, and I'm going to hopefully find that two of them are equal. And if two of the angles in this triangle are equal to each other, then it's an isosceles triangle. So let's do that. Okay, so to begin with, what I'm going to do is I'm going to find the size of angle DGH, because angle DGH and angle DGF make a straight line. So if we do 180 degrees, so 180, take away 100, that's equal to 80 degrees. So that means the angle DGH is 80 degrees. So we found the size of that angle, and let's actually give a reason for that, that angle. Okay, so that's our reason, that angle DGH is equal to 80 degrees as the angles in a straight line add to 180 degrees. Okay, so we found the size of this angle. Okay, now what I'm going to do is I'm going to look at angle EDH, so this 50 degree angle here, and angle DHG. So as you can see, we've got this alternate angle, that Z shape, that alternate angle. So if this is 50 degrees, this angle down here is 50 degrees. So that's a 50 degree angle there. So let's write that down. The angle DHG is equal to angle EDH because alternate angles are equal. So let's write that down. Okay, so I've just written down the angle EDH equals angle DHG as alternate angles are equal. Okay, next, so we've now found these two angles. Let's find the size of this angle here because the angles in a triangle will add together to be 180 degrees. So if we add these two angles together, so if we do 50 degrees plus 80 degrees, that's equal to 130 degrees. And then if we do 180 take away 130, that's equal to 50 degrees. So that means that this angle at the top, angle GDH, is equal to 50 degrees as the angles in a triangle add to 180 degrees. So let's write that. Okay, this is fantastic. We've now got, if we have a look at our triangle, DGH, the triangle that we want to show as isosceles, we've got the two of the angles are equal to each other. That angle GDH equals angle GHD. And if two of the angles inside of that triangle are equal to each other, that's an isosceles triangle. So let's write that. And that's it. I've just written down that as two angles, GHD and GDH are equal to each other, the triangle DGH is isosceles. And that's it. We've shown what we were asked to show, the triangle DGH is isosceles, and we've given our reasons. Okay, so let's have a look at question number 14. So question number 14 says the lines DEF, so DEF, and GHI, so GHI, are parallel. And we can see that with the arrows. So if we have a look here, we've got the little arrow here and here. So we've got those two parallel lines, and the question says work out the size of angle IHP, so IHP, and it's labelled with that little X. And we need to give reasons for each stage of our working. Okay, so we want to find the size of this angle here. So the first thing I'm going to do is I'm going to work out the size of this angle here to begin with, because here we've got a straight line. We were told that DEF was a straight line, so that means we can work out the size of angle HEP. So we can do that by doing 58 plus 30 is equal to 88 degrees, adding together these two angles, and then we're going to take them away from 180, so 180 subtract 88 is equal to 92 degrees. So this angle here is 92 degrees. So let's write that down. Okay, so I've written down the angle HEP, so angle HEP equals 92 degrees because the angles in a straight line add together to be 180 degrees. Okay, so now we want to find the size of this angle. So what I'm going to do is I'm going to consider this triangle HEP, and the angles in a triangle will always add together to be 180 degrees. So if we add together the 92 degrees and the 37 degrees, so let's do that. So 92 plus 37, so 2 plus 7 is equal to 9, so put the 9 down. 9 plus 3 is equal to 12, so that's 129 degrees. So these two angles add together to be 129 degrees. So we're now going to do 180 subtract 129 degrees. And let's see what we get. And that'll be the size of angle EHP. So 0 take away 9, well, let's borrow, so that's a 7 and a 10. 10 take away 9 is 1, 7 take away 2 is 5, and 1 take away 1 is 0. So that's 51 degrees. So this angle here, angle EHP, is 51 degrees. So that's fantastic. So let's write that down. Okay, so I've written down that angle EHP is 51 degrees as the angles in a triangle add to 180 degrees. Okay, now we want to find the size of this angle here, this angle PHI or IHP. Now if we want to find the size of this angle, I'm thinking if we have a look here, we can find the size of this angle here, angle EHG. And if we find the size of angle EHG, we have this straight line, and then we can add together the angle we've just found, the 51 degrees, and then take that away from 180 degrees to find the size of this angle X. So let's do that. So we want to find the size of this angle. So we could consider alternate angles. So for instance here, angle FEH and angle EHG are alternate angles. So we've got that backward Z shape. So this angle, this obtuse angle, will be the same size as this obtuse angle. So to find the size of this angle, we would do 30 plus 92. That'll be the size of that angle. And then once we find the size of that angle, the whole way across, then that'll be the size of that angle because alternate angles are equal to each other. So that's one way we could find the size of this angle. Actually, what I'm going to do is I'm going to consider co-interior angles. This angle and this angle, they're inside the parallel lines. So we can see our two parallel lines. So these two angles will add together to be 180 degrees. So if we do 180 subtract 58 degrees, so 0 take away 8, well, let's borrow, so that's now 7 and a 10. 10 take away 8 is 2. 5 take away 7 is 2, and 1 take away 0 is 1. So that's 122 degrees. So that's the size of that angle. Also, as I said, remember, we could consider those alternate angles. So if we do 30 plus 92, that's 122 degrees. So that means that angle EHG would also be 122 degrees because alternate angles are equal to each other. So either approach. So I'm going to write down the approach for co-interior angles. So let's do that. Okay, so I've just written down the angle EHG equals 122 degrees as co-interior angles, because it's co-interior with angle DEH, they add to 180 degrees. So we've now found the size of that angle. Now we want to find the size of X. So if we want to find the size of this angle X, angle IHP, well, we're going to add together the 122 and the 51, and then we've got a straight line. So if we take that away, that answer away from 180 degrees, we can find the size of this angle labelled X. So let's do that. 122 plus 51 is equal to 2 plus 1 is equal to 3, 2 plus 5 is equal to 7, and then we've got 1, so that's 173 degrees. If we add this angle and this angle together, that's 173 degrees. And now if we do 180 subtract 173, that's equal to 7. So that means that X is 7 degrees. So let's explain that. The angles on a straight line add together to be 180 degrees, and that's how we found that X was 7 degrees. And that's it. I've just explained that angle IHP is equal to 7 degrees as the angles in a straight line add together to be 180 degrees. And that's it. Okay, let's have a look at our next question. Okay, so question number 15. So question number 15 says PQR, so PQR and PSTU are straight lines. So that's a straight line and that's a straight line. And we're told that QS, so QS and RT are parallel, and you can see that with the arrows. And then we're told the angle PQS, so angle PQS is labelled here, is 46 degrees. And then we're told the angle RTS, so the ratio of angle RTS, so this angle, to angle RTU, this angle, so these two angles, are in the ratio 7 to 3. Obviously, as you can see, this obtuse angle would have to be bigger than this acute angle, so that's why it's the ratio 7 to 3. And the question says, work out the size of angle RPU, it's labelled X, and we're to give reasons for our answer. Okay, so the first thing I'm going to do is I'm going to look at this ratio, and I'm going to use this ratio to work out the size of angle RTS and angle RTU. So I'm going to find the size of these two angles, because we know that then the ratio is 7 to 5. So if then the ratio is 7 to 5, if we do 7 plus 5, that's equal to 12. And now we know the angles in a straight line add together to be 180 degrees. So if we take our 180 and divide that by 12, how many parts there are? 180 divided by 12 is 15. So there's 15 degrees in one part, so in one part. And if we want to find the sides of angle RTS, so angle RTS, we would take our 15 and we would multiply by its number in the ratio, which is 7. And 15 multiplied by 7 is equal to 105 degrees. So that means that this angle is 105 degrees. And if we want to find angle RTU, we would take the 15 degrees, how many degrees are in one part, and then we'd multiply by its number in the ratio, which is 5. And 15 times 5 is 75 degrees, so that is 75 degrees. So we've just shared 180 degrees in the ratio 7 to 5, and we've found the size of angle RTS and angle RTU. And we've been asked to explain our reasons, so let's just explain that. And I've just explained that angle RTS, so angle RTS and angle RTU add together to be 180 degrees as they're in a straight line. And as they're in the ratio 7 to 5, angle RTS is equal to 105 degrees and angle RTU is equal to 75 degrees. So that's our first step. Now we want to find the sides of this angle labelled X, angle RPU. And because we want to find the sides of this angle, it'll be quite useful if we consider this big triangle, this whole big triangle here. If we can find the sides of this angle up here, then we would have a big triangle, triangle PRT, and then if we knew the size of these two angles, we could add them together and take it away from 180 degrees to find the size of this angle. So let's do that. Let's find the sides of this angle here. Now if we have a look here, we've got two parallel lines. We're told that in the question that the line QS and the line RQ are parallel to each other. So that means that this angle is actually corresponding to this angle. If we have a look here, we've got this line, and you got that line that crosses them. This angle will be the same size as this one. So this angle up here is going to be 46 degrees because they're corresponding angles. So let's explain that angle TRP is equal to angle SQP because they're corresponding angles. So let's explain that. And that's how I've explained that angle PQS is equal to angle PRT, and they're both 46 degrees as corresponding angles are equal. So the angle PQS and angle PRT are both 46 degrees because those corresponding angles are equal to each other. Okay, so that's fantastic. We've now got this big triangle, triangle PRT, and we've got the size of two of the angles. We've got the size of this angle, the size of this angle, and we now want to find the size of that angle. So if we take our 46 degrees and we add 105 degrees, now this is a calculator question, so you could work that out on the calculator if you wanted to, or you could just add them together to get 151 degrees. So that's the size of those two angles added together. And then if we do 180, take away 151, that's equal to 29 degrees. So that means that this angle X is 29 degrees. So let's explain that angle RPU is equal to 29 degrees because the angles in triangle PRT will have to add together to be 180 degrees. So let's do that. And that's it. I've just explained that angle RPU is equal to 29 degrees as the angles in triangle PRT add to 180 degrees. And that's it. Okay, and let's have a look at one more question. And let's just write our answer down, 29 degrees. Okay, and let's have a look at one last question. So question number 16. So question number 16, we're told that the lines A, B and CD are parallel lines. So A, B and CD are parallel lines, and we can see that with the two little arrows. And then we've got some algebra here. We've got some algebraic expressions. The size of this angle is 7x minus 40 degrees, and the size of this angle is 5x plus 10 degrees. And this angle is an obtuse angle, and this angle is an obtuse angle. And the question says to work out the size of x. We want to work out the size of x. So if we wanted to work out the size of x, well, let's have a look at these angles. This is an obtuse angle. So this angle here, and actually we've got our two parallel lines. So this angle, the bottom left hand one here, will be corresponding to this angle here. So if this is 7x minus 40, this angle here would be 7x minus 40 because they are corresponding angles. Now in this question, we don't need to give any reasons. We just need to find the size of x. So that's fantastic that that angle is the same as that one because corresponding angles are equal to each other. Now we've got two straight lines. If we look at this line CD and this line that goes across, there we've got two straight lines across each other, so the vertically opposite angles are equal to each other. So that means we can write 7x minus 40 equals 5x plus 10. So let's do that. 7x minus 40 equals 5x plus 10. So that's an equation. So just to recap that so far, we had this angle. We said that's corresponding to this one. We've got our corresponding angles. Think back to corresponding angles. So they're corresponding. So we wrote 7x minus 40 there. Then if you've got two straight lines across each other, the opposite angles are equal to each other. So 7x minus 40 equals 5x plus 10. Now we can just solve this equation and find x. So let's solve this equation. So if we've got an equation with letters on both sides, I'd like to get rid of the lowest number of the letter. So we've got 7x's and 5x's. So I'm going to take away 5x's, and I'm going to take away 5x's. So on the left-hand side, if we take away 5x's from the 7x's, we're left with 2x, but we've still got our minus 40. And then on the right-hand side, we had 5x plus 10. We're taking away the 5x, so we're just going to be left with plus 10 or just 10. So we've got that 2x minus 40 equals 10 by taking away 5x's from both sides of that equation. Now, if we want to solve this equation, let's add 40 to both sides because we want to get rid of this minus 40 on the left-hand side, so we're going to add 40 to both sides. On the left-hand side, we had 2x minus 40. We're adding 40 to get rid of the minus 40, so we'll just be left with 2x. And on the right-hand side, we had 10. We're adding 40, so that's 50. So we've now got the 2x equals 50. We don't want 2 multiplied by x, we just want to find out what x is. So let's get rid of this multiplied by 2. So we're going to do the inverse operation. We're going to divide both sides by 2. So 2x divided by 2 would just be 1x, or x, so x. And then 50 divided by 2 is 25. And that's it. And if you need to recap this, there's a video on solving equations with letters on both sides on Corbettmaths. I think it's around about 113 or 14 or 15 or something like that in Corbettmaths, or maybe 114. But have a look around about that region, or search for equations with letters on both sides, or letters on both sides on Corbettmaths, and you'll find a video tutorial there on solving equations with letters on both sides. And that's it. So we've worked out the size of x. X is 25 degrees. So 25 degrees. And that's it. And that's it. So these have been the video solutions to the angles and parallel lines practice questions. I really hope you found this video useful. If you need any extra help on angles and parallel lines, or there's alternate angles or corresponding angles, co-interior angles, or vertically opposite angles even, if you go to Corbettmaths, go to the videos and worksheet section and scroll down to video number 25. There's a dedicated video tutorial there on angles and parallel lines. Alternatively, you can scan this QR code. But in this video, we're focused on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers.